Hello everyone, today we are going to see chapter 4 of class 12 chemistry. The unit's name is the D and F block elements. So this is coming under the inorganic chemistry part. Okay, so we will first see what are the D and F block elements. For that, we will see the periodic table of elements, right? So mainly we have bonds called the two columns. It means electrons in these all elements is we have learned about p block. P block means the valence shell is, and then now we are going D block element. P block valence shell of electron is a D subshell, and for F block elements a region. And now coming to F block elements, F block elements means the last shell on which electron is shell. So this is how we are categorizing elements in the periodic table based on the valence shell of this element on which the last electron is entering is the basis of categorization of elements into D block and F block elements. So D block elements are also known as transition metals, also known as inner transition, other name of elements. So now in this unit, in this chapter, we will see some of the general properties of this D block as well as F block elements. Why these are called transition metals is the fact that earlier these elements name was transition metals because it is observed that this metals have a property that is in between this S block as well as P block elements. So there is a transition from the metallic S block elements to the non-metallic P block elements through these elements. Therefore, these are known as transition metals. And they are all metals. What are metals? Metals are those which can lose an electron to be a positively charged ion. So these all are metals which have a tendency to lose electrons when coming in near to other non-metals. And coming to the F block elements, there are two rows of F block elements known as lanthanides and actinides. Lanthanides is starting from lanthanum with the atomic number of 57, and actinides start with actinium with the atomic number of 69. And for transition metals, so these D block elements, they are mainly 4 rows known as 3D series, 4D series, 5D series as well as 6D series. So there are 4 rows in the case of transition metals and there are 2 rows for F block elements. Transition metals, 3D series, 4D series, 5D series and 6D series. So these all are named on the basis of on which orbital the electron is being filled. So for this, starting from scandium ending with zinc, the 3D orbital is being filled with electron, with the last electrons. And for lanthanides and actinides, the F orbitals are being filled progressively using the last bit of electrons. And now we will see some general concepts about this D block as well as F block elements. So first we will see D block elements or the transition elements. And saying about their general properties, these elements are belong to group 3 to group 12 of the periodic table. They are also known as D block elements. These elements, last electrons enter into the D orbit, that is penultimate. Penultimate means for us, orbital is the outermost orbital, and the electrons are being entered into the 3D orbital. And for 4D, the outermost orbital will be a 5s orbital, and in all these elements, the electrons are entering into the 4D orbitals. So that's how the electron filling up is happening in the case of d block elements. So in the penultimate, that is one behind the valence electron, valence orbital is being filled. And the position is in between s and p block elements. And now coming to the definition. So according to IUPAC, the definition of d block elements is like this. The elements of periodic table belong to group 3 or 12, known as d block elements, because these elements last electron enters the d subshell or d orbital. It's not the IUPAC definition, it's a common definition. By IUPAC definition to IUPAC, the definition is like this. Transition metals are metals which have incomplete d subshells, either in neutral atom or in their ions. So while seeing, we can observe that the group 12 here, zinc, cadmium, mercury, etc., doesn't have an incomplete d shell. They have configuration like this, D10 configuration. So these are not considered as transition elements. So these are exceptions for metals that are not transition elements. So transition elements have d subshell. And therefore, these D10 configuration elements like zinc, cadmium, and mercury are not considered transition metal elements, and they are not regarded as transition metals by convention of IUPAC. Now we will see the electron configuration of this transition metals. So all the transition elements will have the electron configuration like this. This n-1d, that's penultimate d shell, will have either from 1 to 10 electrons, and the valence s shell will have either 1 or 2 electrons. So exceptions are those. Zinc is having this completely filled penultimate as well as valence shells. So these are not considered transition metal elements. The only exceptional cases, palladium here. Here we can see that palladium has 0 electrons in the s orbital. So this is an exceptional case where -1 to 2 is not satisfied. And variations of different electronic configuration are seen across the transition metal elements. For example, scandium has 1 as electronic configuration, but in the case of chromium. So these are exceptional cases of chromium and copper. So we have learned about that in earlier classes, where the extra stability of completely filled or completely half filled orbitals. This makes 4s1 3d 5 extra stable. Therefore, chromium has an electronic configuration of this and copper has an electronic configuration of this, because if the 3d orbital has 10 electrons, that will be a completely filled orbital. So the symmetry energy will be utilized. So this will be more stable. So these are the electronic configuration of all the transition metal elements. So from the periodic table itself, we can see that there are so many important elements in the transition metal. For example, silver, gold, platinum, all these precious elements, precious metals are members of transition metal elements. Other than that, palladium, rhodium, ruthenium, these are those elements which are useful in industries, because they have those precious elements are there, catalyst elements are there, and some color complex like potassium permanganate, potassium dichromate, and iron complex. All these are important transition metal elements. Iron, copper, nickel, all these are highly useful in the industries and technical fields. Rhenium, osmium, tungsten, all these are finding wide varieties of uses in the day-to-day life. So transition metals are an important group of metals in periodic table. So the studying about their properties is a highly useful thing. And because d electrons are more towards the periphery of the atom. So if there is an atom, because of the diffuse shape of d orbitals, if it is in penultimate level also, their shape will be like that. They are protruding towards the outside of the atom. So the influence on surrounding, if there is a negative ion here, this will have greater impact on the surrounding. Other than that, ligands or some other groups of atoms can have greater effect on this d block elements also because of this d electrons nature. And ions of same d configuration has similar anelectronic properties. For example, scandium, ytterbium, lanthanum, and actinium will have same kind of magnetic as well as electrical properties. And one of the main peculiarity of transition metal elements is their varied oxidation state. That means they can have different oxidation states. Some metals can have +2, +3, +4, +5, +7. All these oxidation states are possible in different transition metals. So they can form different type of compounds, different type of complexes with other ligands and all, or the other elements and all. And there is another peculiarity, that is formation of complexes formation. And this complex formation, this complexes formed are highly colored, and they can also form complexes with various ligands. Number of ligands that they can interact and form stable complexes are very high. And there are certain catalytic properties that I have seen for compounds like rhenium, rhodium, osmium, ruthenium, and even iron. All these are very useful catalysts. So catalytic properties is exhibited by majority of the transition metals, and they have paramagnetic behavior. Why? Because of the single unpaired electrons present in most of the elements. They have paramagnetic behaviors. So their magnetic properties also highly studied thing. So this is about the introduction about d block elements, and now we will see f block elements in the next class. I hope whatever I taught in today's class is very clear, and if you have any doubts, please don't hesitate to ask me in the comment section. Thank you for watching. Happy learning.